This afternoon. The weather is beautiful outside. If you were any smarter, you'd be outside enjoying the weather instead of in here listening to me talk about HTML5 video. But I appreciate your lack of good sense, and I hope you'll enjoy this next hour being here with me. I have spent quite a bit of time. Are we catching some feedback here? I've spent quite a bit of time doing web development. But recently, within the past several years, I've been focusing on video in the browser. Hello? Alright. I've been focusing on video in the browser. There are a number of different cable TV providers in the Denver, Colorado area. Denver is where I'm based out of. And Time Warner Cable is one of them. So we'll talk about some of my experiences at Time Warner Cable, but it's very interesting to think that what you would normally expect to be web development using libraries like jQuery and Backbone, and have them running not only on a desktop browser and not only on a smartphone or a tablet, but having them run on a smart TV as well. Doing this development and having it run on a Blu-ray player or a DVD player or a Samsung TV is definitely the direction where the web is going. So if you haven't had an opportunity to do any work with video, I hope you'll think of this as a simple introduction and certainly give you the courage to continue pursuing this. We've seen a lot of innovation from the television manufacturers. But what's really interesting is the innovation has not been around how we watch TV, but more on the device that we are watching it on. So if we look at the improvements in televisions over the years, we've gone from a black and white TV like this to a color TV. We've gone from CRT tubes to LCD screens and plasma screens. We've gone from standard def to high def. 3D TV was something that they were trying to push over the past couple of years. That hasn't really caught on. So the next thing they've been pushing is 4K TV. Have you heard of this? High def, super high def. 4K, ultra high def TV. If standard definition packs 420 pixels onto your screen and high def packs 1080 onto your screen, 4K packing 4,000 pixels onto your screen, you can see it's going to be a dramatic improvement. But again, none of this changes the way we consume our information. They just change how we're doing it, or what device we're doing it on. So while my talk is video is the future of the web, I might suggest that the opposite is true as well. That the web is the future of video, more so than these devices that you have sitting in your family room and your living room. Let me give you some statistics. Now, I apologize, these are North American statistics, not worldwide statistics, but I still think they tell a pretty compelling story. Now, the headline is that Netflix makes up a third of internet traffic in North America. Let me be very clear about this. We're talking about a single website taking up a third of all of the bandwidth. That gives you an idea of how popular video on the web is. Now, if I zoom in a little bit on this, and I know these numbers are small, I apologize about that. You can certainly read them better on the slide deck. But this company, Sandvine, has broken down the traffic in upstream, downstream, and then aggregate numbers. Now, upstream is the data that we are uploading to the server. And so it's not surprising that something like BitTorrent would be the #1 provider of it. What's interesting, if you look at something like Skype, which is a video product. And you don't think of it as uploading, do you? But in fact, when you're doing video conferencing, you are sending that video transmission along there. So Skype is the number 3 bandwidth consumer in the US. But what I find is interesting is Netflix is their number 4. How many of you upload videos to Netflix? Yeah, no one, right? You upload them to YouTube, but you don't upload them to Netflix. The reason why Netflix is number 4 on the upload list is that your device is constantly talking to the server behind the scenes, saying, this is the available bandwidth I have. Hey, I'm not getting all the frames in a timely manner. Will you send them to me more slowly? We'll do this. So this upload information here is strictly metadata. The fact that Netflix is number 4 based on metadata, again, gives you an idea of the volume of the traffic that they're generating. But when we look at the download statistics, which are closer to what you would expect, Netflix comes in at 33% of download traffic. YouTube comes in at 15%. So what we found here are the top 2 bandwidth consumers are taking up nearly 50% of the North American download traffic, and these are video websites. When we look at HTTP and BitTorrent and iTunes, there's no way that we can eliminate video from those, but that's not video exclusively. But then you start seeing things like Flash Video and Amazon Video, and you come to realize that 5 out of the top 10 bandwidth consumers, well over 60% of the traffic in North America, is being consumed by video in one form or another. Do you have any idea it was that large a percentage? I certainly don't. Video is wildly popular. I've got kids at home. I've got an 11-year-old son and a 7-year-old daughter, and I can tell you that they definitely spend more time on YouTube and on Netflix and on Amazon Prime watching their TV shows that way than they do in front of a real TV. There's a real generational shift where folks will assume that what they want to watch will be on their smartphones and their tablets rather than those big glass screens you have in your family room. But we'll talk more about that in this talk. YouTube statistics are always fun because there's such massive numbers. When we start seeing that there are over 1 billion unique viewers, when we start seeing that there are over 4 billion hours of video consumed every month, when we see that there are 72 hours of new videos uploaded every minute, 72 hours of video upload of the web is really consumed by video traffic. And this whole notion of video conferencing, it still seems pretty new and exciting right now. I can't tell you how cool I feel FaceTiming with my kids in Colorado, literally 12 hours away, halfway around the world. And it's a crystal clear real-time picture. The fact that I am not paying a penny for this, that this is a free application, really truly makes me feel like we're living in the future. It really makes me feel like the future is right here, right now. This is going to get more and more commonplace. So, what we want to talk about now for the next hour really boils down to what are the basic players out there. There are 3 players that you need to be aware of, but there's only one that has any kind of long-term future. Once we're past the simple mechanics of video formats, we'll talk about how important mobile is to this video strategy. And then we'll wrap up with some really cool demos on WebRTC, web real-time communication. But let's get things started here. Let's talk about the big 3 video formats that you should be aware of. And they are, hopefully this doesn't surprise anyone, Flash, Silverlight, and HTML5. Now, Flash is the biggest of the bunch today. We find that Flash really came to prominence in the last century, in the late 20th century. It came at a time when there wasn't any real innovation going on in HTML itself. I'm not here to poke Microsoft in the eye. I'm really not. But it came at a time when Microsoft had a 95% market share, and they were doing absolutely zero innovation with their browser, Internet Explorer 6. So what happens as an industry is we kind of routed around that. We said, we're going to find ways that we can bring new features to our browser. We're going to find new ways that we can play games, that we can begin streaming audio and video. And it was very much a plug-in solution. And while there were other solutions out there, Real Audio, QuickTime, other things like that, Flash very quickly rose to prominence and became the go-to plugin for any kind of RIAs, rich internet applications. Certainly, YouTube was one of the biggest consumers, one of the biggest beneficiaries of Flash's rise to prominence. When you're watching video on YouTube, traditionally you've been using Flash. Now, for quite some time, YouTube has offered an HTML5 alternative. And they had to, because Flash was not available on a wildly popular device, the iPhone, back in 2007. So they were forced to come up with different solutions, non-Flash solutions. And once they open that door a little bit, it cracks wider and wider and wider, and you can't ever unclose that door again. And so YouTube, while Flash is still the predominant format for its videos, Google is actively pursuing alternates to Flash, HTML5 being the biggest of both. Now it's good that Google is looking for alternatives because Adobe has deprecated Flash. Flash is dead for all intents and purposes. Now we'll talk more about this here, but it really has kind of become a last century solution. I'm not here to poke an eye in Adobe's, poke a finger in Adobe's eye either, but Flash is definitely a technology that's on the descent instead of on the ascent. Just to give you another simple example, Facebook rose to prominence largely on its games. Zynga was the largest manufacturer, was the largest creator of those games. Zynga was a Flash shop. Now that over half of Facebook's visitors are coming in on mobile devices that don't have Flash available, it's forced Zynga to become HTML5 experts as well and begin developing their games in a way that they can be played on iPhones as well as iPads, as well as desktop computers. So Adobe is well aware of this, and they're stepping away from Flash, and they're really pushing their marketing and development efforts into HTML5. So that's the Flash story. Let's talk Silverlight. Now, Silverlight is Microsoft's solution. When Microsoft was putting this together, they really did mean Silverlight to be their Flash killer. It too is a plugin. It too offers you rich capabilities. You can write games. But where Silverlight has really taken off is not so much in game development like Flash, but really when it comes to videos. Any of the Olympic footage that you are watching on your mobile devices are most likely coming to you through Silverlight. Now, Silverlight is also the primary technology that Netflix is using. I should say, was the primary technology, because Microsoft officially end-of-lifed Silverlight. And when that happened, Netflix said, oh, well, we ought to be looking at alternates as well. Now, you have to realize that Netflix is already intimately familiar with HTML5 video because they're using it everywhere besides the browser. In the desktop browser, they were using Silverlight. But Silverlight isn't available to you on iOS devices, but yet you can watch Netflix on your iOS devices. Flash is no longer available to you on Android devices, and Silverlight never was. And so anytime you wanted to reach out, watch videos on your Android devices. Anytime you wanted to watch videos on your smart TVs, anytime you wanted to watch videos on your Blu-ray players, on your DVD players, all of those were using a non-Silverlight client. So when Microsoft has deprecated Silverlight, Netflix is saying, well, even though this was our largest client, we certainly have the expertise to move past it. I love this headline. Our strategy with Silverlight has shifted. And by shifted, we mean there's not going to be a Silverlight 6. We have end-of-life Silverlight 5. We have taken down the developer portal, and we've not mentioned it in any of our major conferences over the past 3 years. That's how they shifted their strategy. Yeah? That's a pretty clear shift, isn't it? So we said that we have 3 major players, Flash, Silverlight, and HTML5. And in each case, we find that the alternate is skewing towards HTML5. And one big part of that skew is because plugins, whether they're Flash plugins, or Silverlight plugins, or Java plugins, or QuickTime plugins, those have become the #1 attack vector for spreading viruses through browsers. JavaScript itself is sandboxed in such a way that you can't write an effective virus in JavaScript. And so if you want to get malware on someone's device, what you'll do is you'll come in through the back door. You'll come in through Flash, you'll come in through Silverlight, you'll come in through Java, or any of these others. It's gotten to the place now where we used to, every time you installed a new operating system, your browser would come with all these plugins turned on and pre-configured. It's gotten to the place now in the latest versions of these browsers, they're coming without these plugins installed and with things, especially Flash, explicitly turned off. So in this article, these are just 2 studies. One study in 2011 found that 40% of all Java plugins were unpatched for some kind of attack vector. There was another study that said 70% of all Java plugins were unpatched. You get the idea, though, that whatever that number is, having to not only upgrade your browser, but upgrade all your plugins, and then dealing with synchronizing 2 different upgrade cycles, that's not a long-term recipe for success. So this article says the future is plug-in less. And I certainly agree with that as well. Which brings us to HTML5 video. What we mean by plugin-less is I have got a video element that's native to the browser. No plugin required. So just like you can do an image source, or you can do a script source, you can now also do a video source. And it is a container element, so if for some reason that browser can't download the video or can't play it, you can have some text that shows up that says, hey, for some reason I was unable to play this video. Now this is the simple form of this, but unfortunately, if you're trying to come up with a cross-browser solution, you'll almost never use this simple. If you're behind the firewall, if you're in an organization that is standardized on IE, then you might be able to have video content that you know will play on that standard browser, so you can use this simple version. But for any kind of public video consumption, you're going to end up using the expanded version, where you have video with source elements inside of that block. And what your browser will do is it will start reading that list sequentially. And if it can't understand the first codec, it'll go to the second. If it can't understand the second codec, it'll go to the third. And eventually, it'll either find a version of that video that it can play, or it'll display the text. This is so powerful that most of the time, you'll end up doing something like this, where you'll start with WebM and OGG and MPEG-4, and if it can't play any of those, you can fail back over to Flash. Most websites will end up standardizing on two formats. They'll try to serve up MPEG, and if they can't do that, they'll fail over to Flash. And it's nice that out of the box, we can do that. Now granted, Flash is a plugin, but what we're trying to say is, if you've got native support for this video, go ahead and play it, and if you don't, we'll defer to that plugin. So this code right here will work across 100% of the browsers on the market, including IE6. So you look at something like this, and boom, problem solved. The one thing that you should stop looking for, it'll only break your heart, is that there is not a single video format that can be played across all browsers, across all devices. You're going to have at least 2 video formats, if not more. And that's why I said, if you end up going with MPEG and Flash, you've pretty much got the market covered. Because your Flash will cover all of your desktop browsers, and MPEG will cover everything else. All your smartphones, all of your tablets, all your smart TVs, Blu-ray players, so on and so forth. So that is our story on the video formats. Here's where it gets fun. What are we going to do when it comes to these mobile devices? Why should I even care about mobile devices? Well, here's one reason. In 2011, Apple sold more iPads in 1 year than the entire number of computers it had sold in the history of the company over 30 years. Let me say that again. In 1 year, they sold more tablets than they had sold computers over the entire life of the company. This is a statistic you'll see repeated over and over and over again. And I know the numbers are incredibly small. It's not important that you can read the individual numbers as much as you can see the trends. So this green line right along here are their Macintosh sales. These are years along the bottom right here. This line is the 50 million mark. So we can see that it took them about 20 years to sell 50 million computers. It took them 3 years to sell 50 million iPods. It took them 2 years to sell 50 million iPhones. And it took them 1 year to sell that many iPads. So when you look at this chart and you see growth trends like this versus growth trends like that, it gives you an idea of what horse you want to bet on in a race, isn't it? Now, while this statistic is unique to Apple, the only reason I would have brought it up is that we see this statistic playing out across all vendors in the industry. In 2010, smartphones outsold computers for the very first time. And those trend lines match exactly what we were looking at before. PC growth was 5% year over year. Smartphone growth, 90% year over year across the industry. When it comes to tablet sales, last year, 2012, 1 in 4 computers sold were a tablet. Looking at numbers like this, 2013 is the year they're expecting tablet sales to exceed PC sales. So 3 years ago, smartphones began outselling computers. This year, tablets are going to outsell computers. Again, where are you going to put your money? Where are you going to put your development efforts? Mobile is not a segment you want to ignore. Last year, Google had 1 billion people, with a B, 1 billion people using mobile devices as the primary way to access Google. Those are real numbers, aren't they? And so in light of all these statistics, when Adobe announces that they are dropping support for flash on mobile devices, it's a huge run in the wrong direction. Now, Adobe is aware of this. They know that the future of web development is mobile. But they were unable to get flash on the iPhone. And they initially were able to get flash on Android devices, but Google quietly pulled flash support from Android devices as well. Because Flash was a very good solution for desktop browsers in the 20th century. But in the 21st century, with these mobile devices, we find that Flash was just not the correct solution. Am I phrasing that well? I'm trying to be very honest about this. Last century, Flash was exactly the right solution. This century, not so much. Apple, specifically Steve Jobs, is popularly credited as the one who killed Flash. He was the man who killed Flash. And the conventional wisdom was he killed Flash because Apple had an app store. And he wanted all of the money. He didn't want to share that money with Flash. He didn't want to have Flash games coming onto his devices. The conventional wisdom was he wanted to control the money from start to finish. I think that's probably part of the truth. I don't think you can deny that. He was an incredibly savvy businessman. But what I liked about this blog entry, Thoughts on Flash, is a perspective. He says, number one, Flash is not open. Flash is a proprietary plugin that uses proprietary languages controlled by a single company. Now, who was I talking about again? Was that Apple or was that Adobe? I'm confused. Yes. Those same arguments could be leveraged against that. And Steve says that. He's like, hey, we've got a ton of proprietary products as well. The operating system for all these things are proprietary. But he says, we have really invested a lot of effort in our HTML5, CSS, JavaScript. We have really invested a lot of effort in solutions that run across devices. Not just our devices, but other devices as well. That's an important thing to keep in mind. Now he says, in addition to it being a closed source system, Adobe popularly said, well, you don't get the full web. You can't play games on your device. You can't visit YouTube on your device. You can't do those things. He said that iPhone was web the lesser. Well, now, in fact, what we figured out was that in 2007, when the iPhone came out, we were able to watch those YouTube videos. Google transcoded all of their Flash videos into MPEG so they can be played on the devices as well. You don't notice that as a consumer. You pull out your device and you start watching dogs on skateboards. And if you're on your iPhone, you're getting it as HTML5 video. If you're on your desktop, you're getting it as Flash. You don't much care. You're still watching dogs on skateboards, right? But this full web argument maybe would have been true back in the late 90s, but it certainly wasn't true by 2007. And as a matter of fact, what we're finding is the lack of Flash on these devices didn't make the devices less popular. It made Flash less popular. It forced Facebook to develop their non-Flash strategy. It forced Twitter to develop their non-Flash strategy, and YouTube and Netflix, and on, and on, and on. When you see growth curves like this, you pay attention to these numbers, and they make a big difference. third thing he brought up is something we've discussed already, the reliability. The Flash plugin is the #1 most cited buggy plugin. I don't know if you've noticed this on your Windows devices. Since it was written for Windows initially, Flash isn't nearly the bad citizen on Windows as it is on different devices. It's a rust. I expect my iPhone to be able to get through at least an 8-hour workday. If it can't last the day, it's not doing me much good, is it? What's interesting about Flash, and we're going to use this as an excuse to take a deeper dive in, Flash used a codec, a compressor-decompressor algorithm that was implemented in software. HTML5, specifically H.264, that's the codec we're going to talk about more, is implemented in silicon as a chip on your phone. It's because H.264 is not only what iPhones use, it's what Android phones use as well. It's what iPads use and Android tablets. H.264 is what your cable company sends down the wire if you have digital cable. It's what your satellite company sends down the wire, DirecTV Dish Network, if you have satellite TV. H.264 is what DVDs use, is what Blu-ray players use. Since it is so pervasive, it's gotten to the place where even the Raspberry Pis or the BeagleBones, those little $30 micro single device computers in there, those have MPEG chips on them. Those have MPEG decoder chips on them. It's become such a commodity that you can throw it on for near to nothing. And hardware will beat software every day of the week. If you want to put real numbers on it, on an iPhone, playing back H.264 videos that are using the hardware gave us about 10 hours of watching videos. Videos decoded in software gave us less than half that. And Steve is actually being very generous. At Time Warner Cable, when we were looking at this, we could typically get just about the length of a feature film encoded in Flash to play back on an iPhone before it ran out of batteries. Whereas literally, we could play video for as long as the normal work cycle of that device would be. That is the biggest difference right there, is a software codec versus a hardware codec. Does that make sense? Yeah. Excellent. So codec is a portmanteau. It's a combination of two words, coder, decoder, or compressor, decompressor. But you can see that's the algorithm that gets used. And if you have that codec in hardware, you're going to get battery life. And battery life is the #1 most important thing on these little mobile devices. So, to put this into perspective, you've got containers and you've got codecs. Now, it's easy for us to think of containers because those are the files, that's the extension that's on the end of it. If you've got an MP3 file, you think to yourself, okay, I've got a music file, I know what's inside of that. MP3 is the container, but it's also the codec, the algorithm inside that's in there. A container is really more like a PK zip file, or a tarball, or a bzip. Because when we start looking at an MP3 file, it not only has the audio in there, it might also have the metadata, like the artist, the album, the track, the lyrics, the duration, all of that good stuff. It might have box art in there, it might have photographs, it might have a number of things. So these containers can contain a bunch of things. We're talking specifically about the H.264 codec. So when I have an MPEG-4 file, that's the container, but it's got an H.264 codec, and that codec is what's in silicon. Flash normally used the FLV container. That was the file that would come down Flash video. It could also be FLA, Flash audio. Now what's interesting is Flash normally wouldn't read H.264 video. But one of the things they did is they said, oh, well, we can do that. We can support that codec inside of the flash container. That would solve half the problem. If we had flash on a device, I could open up that container and read it. Yeah, that didn't happen. Silverlight used its own codec, VC1. They said, oh, we could throw H.264 inside of a Silverstream file. We could do that. The only problem was you didn't have a Silverstream client on your mobile device that could read these things. So it is really a chicken and egg kind of scenario. Does that help clarify the difference between a container and a codec? And specifically H.264 is a codec. So H.264 is not without a bit of controversy. People who are not fans of H.264 like claiming that it is patent encumbered. And they're not wrong. MPEG is a format. Now, we as an end user will never be charged for watching an MPEG video. It's the provider. If you transcode, if you serve up MPEG videos, you don't have to pay anything for less than 100,000 views. But if you get more than 100,000 views, that's what triggers the licensing. That's what triggers those payments. Now, the good news is we'll never see that charged to us as a consumer. But also, the people who are paying those prices are the browser manufacturers. So Microsoft supports H.264 and Internet Explorer. They paid the licensing fees for that. Apple supports H.264 and Safari. They paid the licensing fees. Google is paying the licensing fees for H.264. They chose not to include it in several of their browsers for political reasons, not because they didn't already pay. Firefox doesn't support H.264, but they don't support it for political reasons. They said, we are an open source browser. We support open, non-patent encumbered technologies. And so they have a political reason for not including the H.264 codec. But you know what? That battle's really almost lost. The Firefox folks and Mozilla folks have kind of thrown up their hands and said, all right, well, I guess we will at least allow the operating system or the application provider to provide that H.264 codec. We won't ship it with our browser, but if it's available in your operating system or another application or a plugin, we'll support it that way. But it's interesting. No, the text is very small up here. But Google had already taken all of its YouTube videos and transcribed them from Flash to H.264. And they said, you know what, if we did that once, I'll bet you we could do it again. They came up with this web format called WebM. And we'll go into all the details, but their theory, at least, was WebM had all of the quality of H.264, but it wasn't patent encumbered. It got tested in court. Guess what? It is patent encumbered. And so all of a sudden now you have a really nice file format. It produces really nice video, very high compression. But it is just as patent encumbered as MPEG is, as H.264. And you don't have any codecs in silicon. So this is the Flash story all over again, isn't it? It's a very nice codec, but you don't get the hardware benefits. Microsoft, with their Silverlight, had their own codec, VC1, and they said, hey, we're not patent encumbered, we're not patent encumbered. In fact, they're patent encumbered as well. So, what we're left with is H.264, a very nice format that you and I are never going to pay for in our entire life. It just has a cost associated with it that's being borne by someone else. Does that help? Yeah. So, streaming is another thing that we need to keep in mind, especially when it comes to mobile devices, because mobile devices are mobile. That's the whole point of them. So when we were watching YouTube videos in Flash, it was like dropping a bomb on our browser. in that it was one big file that was getting downloaded. Now, in the bad old days, you'd have to wait for the entire file to be downloaded before that video would start playing. That's because MPEG was created in a time before the web was really a consideration. All of the metadata, all the headers, were at the back end of that MPEG file. So when you were downloading it, you had to wait for the entire file to get downloaded until you could check Summit and see what the duration was and all that kind of good stuff. They did this radical thing where they allowed the headers to be pushed to the front of the file. So all that metadata would be read in initially, and then you could start watching the video as it's downloading it. You've seen this in YouTube, right? Even my kids know that there are two bars you need to pay attention to. The red bar is your progress on the video that's being played, but the faded out bar behind the scenes is the download process. And if the red bar outruns the download process, they figured out that what do? They just replay the video from the very beginning. And they kind of keep replaying it until the rest of that video is downloaded. I mean, this is an easy problem to solve if you're a 7-year-old. We'll play it again. But it really is not a real solution to the problem. What we want is a format that is adaptive. We want a format so if I start watching a video in here on Wi-Fi, and then I walk outside and I flip over to the cellular network, I can continue watching that video. Now, if I'm dropping a bomb on my browser, if I've got something that's appropriate for Wi-Fi and I walk outside on the cellular network, what am I going to get? Buffer, 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 buffer. Right? But with an adaptive stream, my phone is constantly talking back to Netflix. And my phone is saying, not getting the frames fast enough, I'm beginning to stutter, I'm beginning to jag. So what it'll do is it'll dynamically, on the fly, start downloading easier frames, lower bandwidth, lower resolution frames. That's why Netflix is the #4 upload consumer. That absolute metadata, that absolute conversation going back and forth between these devices, the adaptive nature of web video is why Netflix is the #4 upload consumer on the network. So this adaptive bitrate streaming means we're no longer downloading one big file. What we're doing is we're chopping our video into segments. And it's fairly arbitrary. Apple uses 10 seconds. Microsoft uses 2 seconds. Flash uses 4 seconds. But all that stuff is tunable. We all have the same basic idea. Rather than taking one big file, we'll chop it up into little files. And that way, if I'm inside, I get the high bandwidth 10-second segments. And when I step outside, I get the low bandwidth 10-second segments. Does that make sense? Excellent. So Apple's standard is called HLS, HTTP live streaming. Now they have gone so far as to hand this off to IETF and have it standardized. And so a lot of people look at HLS and they turn up their nose and that's that Apple proprietary standard. What you have to realize is this is a pattern that's played out before. Apple had a proprietary format called QuickTime. They standardized it. They handed it off to IETF, and it became the MPEG standard that everyone uses. And so Apple started with a proprietary solution, standardized it, now it's being used across cable providers and DVDs and Blu-rays and everything else. I'm anticipating the same thing will happen here, that they came up with a proprietary solution that works, but they've proven out in the wild, let's standardize it and let people use it. So Apple's is called HLS. Adobe's is called HDS, HTTP Dynamic Streaming. Microsoft's is called Smooth Streaming. Again, these are 3 different implementations, but conceptually the same. So there is a standard that's emerging called MPEG-. The dash stands for dynamic adaptive streaming over HTTP. They just tried to get all the verbs in there that they could, and come up with something. Dash is kind of a cool word as well. So MPEG dash will be a way to kind of formalize, standardize this kind of thing. But realize once again, whether we're talking HLS or HDS or smooth stream or dash, none of this is promising a single format that will work across all devices. Because at the end of the day, devices are very different. That smartphone has a different set of CPUs and battery and performance characteristic than an 8-core processor or a 64-core processor up there. So the idea that we could have one video format that would work across this wide disparity set of devices is one that we just have to kind of give up on. We have to come up with these formats that make it very easy for us to apply a number of solutions and let the device self-select. This is an example out of HLS. But we can see that if I'm coming in at this bandwidth, I want you to download this file and start using it. If you come in at this bandwidth, I want this to be used, and so on and so forth and so on and so forth. And so what you end up doing is not only providing both Flash and MPEG video, you end up providing no less than about half a dozen versions of that MPEG video at 720 for high def, at 640, at 480, and smaller resolutions as well to help with these devices when they're adapting their bandwidth. But at the end of the day, what you're going to end up with, again, this is HLS, you'll see this is one 10-second segment, this is the next, this is the next, this is the next. And so as your player is downloading these 10-second segments, if it finds that I can't download them fast enough, that I'm beginning to stutter, what I'm going to do is go back to the previous manifest and start requesting those same video segments, those same 10-second segments, but I'm going to be requesting the lower bandwidth version as opposed to the higher bandwidth. Yeah? Very cool solution. Now we get to the fun stuff. Now we get to WebRTC. Because this is going to unleash a whole new set of capabilities. Something that's going to make you want to pat Netflix on the head and say, you're kind of cute, but I can do some really cool stuff now. So WebRTC is just that, real-time communications. It is a JavaScript library that once it's implemented across all browsers, it'll give you a JavaScript API to control the video camera. It'll give you a JavaScript API to control the microphone, and it'll also give you the ability to control speakers and output and headphone jacks and good things like that. Now what's interesting is that this is something that Google created and have now handed over to IETF and is in the process of being standardized right there. So this is a very common practice once again. Every technology has to come from someone, and what we have to do is congratulate them, applaud them for standardizing it. JavaScript itself started as a proprietary Netscape implementation. They reached out to ECMA, the European Computer Manufacturers Association, and standardized it that way. But WebRTC, unsurprisingly, is available in Chrome right now. And I have to verify this, but I'm almost positive it's shipping in the mainstream Firefox versions right now. Need to double check that. Because Mozilla just recently announced a project called Tow Truck. Have you heard of Tow Truck? It's a way for you to provide collaboration on your website. Now, one of the things Mozilla Labs right now, but it's definitely something worth downloading. It definitely works in the latest versions of Firefox. You and your peer at work should both sit down and download it, be sitting at two desks next to each other, and collaborate. But here's where it gets really fun. Here's where it gets fun. Some of the examples in this slide deck, this is by Sylvia Pfeiffer, by the way. She has written the definitive book on HTML5 video. It's called The Definitive Guide to HTML5 Video. She's sitting on all the standards committees. She's a consultant doing these kinds of things. So it really is a wonderful go-to book. But now is the time to move to the live demo portion of this presentation. So she starts here saying, let me show you the simplest possible example right here. So there's my video. And what I'm going to do is I'm going to get user media. And I'm either going to get the video or I'm going to get the audio aspect of this. And then once I have that, what I'm going to do is I am going to send that stream to this little object. So what I've got right here is pure JavaScript. Hello. Right there. No plugins at all through JavaScript. Literally this amount of code being able to give me real-time video in my browser. That's pretty cool, isn't it? But wait, there's more. Because that is just beginning to scratch the surface. Let me see here. In WebKit it's this, in Opera it's this, in Firefox it's this, Moz. Yeah, that doesn't surprise us, does it? When it really comes to the fun things are when we start doing things like this. You'll see this redirected me to webcamtoy.com. When I come in here, you'll see that I will always be prompted to use this camera. It's never going to use it without my will, against my will, without me knowing about it. But once I give it access, I can not only come in here and do this, I can start having all kinds of fun effects, right? Oh, now I've got to do this, right? All right, yeah. Oh, how am I going to do that? Oh, my forehead, look at that. Oh, right there. All right, yeah. So all of this is obviously being done live in the browser. And while this is cute, this is amazing. Because this example right here is not only dealing with audio and video, what it's also doing is beginning to do motion detection. Or with my forehead. There we go, right? But what's incredible about that, do you want to applaud? I really do think you should. Isn't that amazing? Thank you very much. I didn't write any of that code at all, but I will take your applause. I'll take your applause right there. I was able to click a link just like everyone else would. But that just gives you the tiniest glimpse as to what the future begins to offer. Because what you have now is a pure JavaScript solution, zero plugins, that is not just doing a simple video playback, but what it's really doing is facial recognition. What it's really doing is edge detection on these things, and really allowing you to begin playing with your browser in a whole different way. So again, all this code is available to you online as well. But it just begins giving you a glimpse as to what we can deal with here. So as you're beginning to formulate your video strategy, what you're going to be left with is you definitely are going to need to be able to do MPEG-4. You're definitely going to be able to need to do H.264 because that's the only way you're going to reach the broadest number of devices out there. You will probably want to have at least one failover, and most likely it'll be Flash. Most every website out there that's writing video is providing MPEG with a Flash failover. And if you get that, you get all these devices in place. Once you have that strategy in place, you want to make sure that you've got a good mobile strategy. And that can't be dropping a big bomb. A Netflix movie is about 1.5 gigs. You can't drop that bomb on a consumer. So you need to have a good streaming strategy, one that's adaptive, one that will change based on the bandwidth conditions in your situation. But once you have those two things in place, and once WebRTC gets a little bit more broadly implemented, then all of a sudden, we are really in fun times. And that, my friends, is why I think web is the future of video, and video is the future of web. Did you enjoy yourself? Thank you so much.